Assalamu alaikum, everyone, and welcome. Today, we are going to crack the code on the AS level chemistry practical paper 33, specifically for the February/March 2026 series. If you want to walk into that exam feeling confident and ready to secure those crucial 40 marks, then you are in exactly the right place. Let's dive right in.
Okay, so first things first, a quick disclaimer. What we're about to go through is a prediction, all right? It's all based on looking at historical exam patterns and what the current syllabus demands. It's designed to help you revise smarter, but please know, this is not an official leak of the paper.
So, why are we focusing so intensely on this one paper? Well, look at that number. This single exam is worth a massive 23% of your entire AS level grade. That means every tiny detail. We're talking table headings, significant figures, the words you choose for your observations, all of it can make a huge difference to your final result. So yeah, the stakes are definitely high.
Which, of course, brings us to the big question on everyone's mind. What is actually likely to show up on the paper? Based on the patterns, what can we expect? Well, that's exactly what we're here to find out.
Here's the game plan. We're going to break it down into 4 parts. First, we'll tackle the titration, which is almost a guarantee. Then, we'll move to the calculation-heavy enthalpy question. After that, we'll ace the analysis section, and finally, I'll give you a simple alternate revision plan to tie it all together. Right, let's jump into question 1. Look, this is almost certainly going to be a titration. It's a fundamental skill, and for the examiners, it's the perfect test of your precision and whether you can be consistent when you're under pressure. To score well here, there are 4 golden rules. These are non-negotiable. First, draw your results table before you even touch any of the equipment. Second, every single burette reading must be recorded to 2 decimal places. Third, you need concordant results. And fourth, you have to include your rough titer in the table. If you leave it out, they will penalize you. So don't throw away those easy marks. This right here, this is what a perfect results table looks like. See how the headings are super clear? And notice the units, cm³, are written just once after a slash. And of course, the rough titer is right there where it should be. This is the gold standard you're aiming for. And this slide hammers home that second rule. It is so important. Writing 24.5, nope, that's wrong. It has to be 24.50. If you get a whole number like 24, you must write 24.00. It's all about showing the examiner you understand the precision of the burette. It's such an easy mark to get and a really frustrating one to lose. So what about that third rule, concordant titers? Well, all it means is you need 2 of your good titers to be super close to each other. We're talking within 0.10 centimeters cubed. In that perfect table we just saw, titers 1 and 2 were concordant. This isn't just good practice. The syllabus actually requires it for you to have accurate results. Okay, let's move on to question 2. Now, this is the heavy hitter. Our prediction is that this will be an enthalpy change experiment, which means it's going to be packed with calculations and it'll almost certainly involve Hess's law. So where does this prediction come from? We've been looking really closely at the October/November 2022 paper 36. In that paper, students had to find the enthalpy of dehydration for hydrated sodium carbonate. It's a classic experiment, and it's great for examiners because it tests so many different skills all at once. At the heart of this question is Hess's law. And really, what is it? It simply means that the total energy change for a reaction is the same no matter which chemical route you take to get there. It's a really clever tool that lets us figure out an enthalpy change that you just can't measure directly in the lab. Now, don't get overwhelmed by the math. There's a clear 3-step workflow. First, you calculate the heat energy, which we call Q. Second, you convert that Q into the molar enthalpy change, or delta H. And finally, you just plug your values into a Hess's law cycle to solve the puzzle and find the unknown. For that first step, you'll use the formula Q equals mc delta T. You've seen it a million times. But please, listen very carefully to this because this is the most common error. The m in this equation is the mass of the solution in the cup, the liquid. It is not the mass of the solid you add. I'm telling you, this mistake costs students marks every single year. Don't let it be you. For step 2, the formula is delta H equals negative Q over N. The most important thing to remember here is the sign. It's simple. If the temperature goes up, the reaction is exothermic, so your delta H must be negative. If the temperature goes down, it's endothermic, and your delta H must be positive. Whatever you do, do not forget that sign. And just like with titration, precision is king here.
2 final warnings for this question. The syllabus says you have to record all your temperature readings to the nearest 0.5 degrees Celsius. And when you get to your final calculated answer, it has to be given to 3 significant figures. Not 2, not 4, 3. In this question, precision is everything.
All right, on to the final piece of the puzzle. Question 3. This is the qualitative analysis section, the observational challenge. It's not about numbers, it's about what you can see. You'll be playing detective, trying to identify unknown salts using the notes they give you at the back of the exam paper. Now, the number one rule for this question comes straight from the Cambridge syllabus itself, and it's golden advice. You have to record all your observations, even when that observation is no change. Seeing nothing happen is a result. It's a valuable piece of the puzzle, and you have to write it down to get the mark. Just as important as what you see is how you describe it. You have to use proper scientific language. We don't say bubbles, we say effervescence. A solution isn't clear, it's colorless. And a solid doesn't just appear, a precipitate formed. Using the correct terms shows the examiner you know exactly what you're talking about. So here's a quick summary of what to look out for. When you're testing for cations with sodium hydroxide or ammonia, you're looking for precipitate colors like white or blue, and you always need to check if they are soluble in excess. For anions like halides, you'll be using things like silver nitrate and describing the precipitate color. And if you see that effervescence, you must go one step further and test for the gas. Okay, let's pull all of this together into your ultimate revision plan. This is a simple summary of exactly what you need to master to walk in there and succeed. So, to recap, for that first quantitative task, the titration, you need to master getting concordant titers and nailing your concentration calculations. For the second one, enthalpy, you have to be a pro at using Q equals MC delta T and building those energy cycles. And for the qualitative task, it is all about precise recording. My biggest piece of advice, go find and practice the October/November 2022 paper 36. That's 9701/36/O/N22 to get a real feel for this exact structure. And that brings us to the end. On exam day, it all comes down to a choice, precision or panic. But with the right preparation, that's a choice you get to make ahead of time. You can choose precision. Practice these skills, prepare well, and you'll be able to walk in there with confidence. You've got this. Good luck.